Okay, let's just state the obvious. We are in the middle of an absolute AI gold rush. And large language models, they're the new frontier. But to get smarter, to get better, these powerful models have this insatiable hunger for one thing: data. And that hunger, well, it is about to hit a massive wall.
And right here, this is the core conflict that AI is facing. I mean, on one hand, these models need a constant diet of new information to learn. But on the other hand, the world's most valuable data, stuff like our medical records, financial data, it's private, it's locked away, and for very good reason. So this creates a huge bottleneck for progress.
So let's really dig into this. Let's break down why the way we currently train these massive AI models is just, well, it's quickly running out of road.
I mean, just think about models like GPT-4 or Llama. Training one of these things is a monumental effort. It's not a small task. We're talking thousands of specialized processors running for weeks on end, burning through just unimaginable amounts of energy and, frankly, money. The sheer scale of it is staggering.
And then there's this number, 2026. Now, this isn't some far-off forecast. You can think of it more like a deadline. Researchers are predicting that by 2026, and that's just a couple of years away, we will have literally exhausted the entire supply of high-quality public data on the internet. We're basically running out of textbooks for our AI to study.
So this leaves AI development staring down three massive walls. First, you've got data exhaustion. The public internet is pretty much tapped out. Second, prohibitive cost, which locks out pretty much everyone except for a handful of tech giants. And the third, and this is the biggest one, is that the most valuable data is completely off limits, locked away in all these private silos.
You know, a bottleneck like this, it forces a radical rethink. It forces you to get creative. What if, instead of bringing all the data to the AI model, we could bring the model to the data? Now that is a fundamental shift in how we think about training AI.
And this brings us to a brilliant concept called federated learning. It completely flips the old model on its head. So instead of trying to move all that sensitive data to some central server, the AI model itself travels to where the data lives, whether that's on a hospital server or even on your phone. It learns locally, and here's the kicker: it only sends back the insights, never the raw data.
This is a fantastic way to picture the difference. Think about it like this. The old, centralized way is like forcing every chef in the world to ship their secret family recipes to one giant central kitchen. It's risky, it's complicated. Federated learning, on the other hand, well, that's like sending a master apprentice to each chef's kitchen to learn their techniques on site, without ever taking the recipe book home. It's a game changer.
So that's the theory. It sounds great, right? But how do you actually make it work in the real world, especially with these enormous language models? Well, some researchers have built a system to do exactly that. Meet Photon. This is the first system that's actually designed to pull this off at a massive scale. Now, I know this diagram looks a little complex, but the idea behind it is actually really simple. Think of it like an orchestra. You've got a central conductor, that's the photon aggregator, and then you have all the individual musicians, the photon nodes, who each hold their own private data or their instruments.
The whole process is kind of like this elegant four-step dance. So step one, the conductor, the aggregator, sends the current sheet music, that's the AI model, out to all the musicians. Step two, each musician practices on their own, training that model with their unique private data. Step three, they don't send their instruments back, no way. They just sent back the improvements they made, the lessons learned. And finally, step four, the conductor combines all those little improvements to create a new, richer, smarter version of the music. And then the whole dance begins again.
Okay, so this all sounds great in theory, but it raises the most important question of all, right? Can an AI model that's trained this way, in this decentralized, privacy-first manner, can it actually perform as well as one trained the old-fashioned, centralized way?
Well, the answer from the research is a resounding yes. And you don't have to take my word for it, just take a look at these graphs. That blue line, that shows a traditional AI model learning in a central place. The orange line, that's the federated model, Photon, learning across all those private data sources. They are almost perfectly identical. This is the proof we needed. We can get the same powerful results without ever having to compromise private data.
And what's more, the system proved to be incredibly robust. So what does that mean? It means it works even when the data sources are all totally different, or even when some of the participants are offline. It's a flexible, powerful approach that's actually built for the messiness of the real world.
So look, this isn't just some clever technical trick. This could fundamentally change the future of how AI is built, and maybe more importantly, who gets to build it.
So what does this really unlock? 3 huge possibilities. First, real privacy. Models can learn from super sensitive medical or financial data without a human ever seeing it. Second, it means better AI. We can finally tap into all that locked away data to build more specialized, more capable models. And third, and this is a big one, it democratizes the whole playing field. A small hospital, a startup with valuable data, they can now help train world-class AI, breaking the stranglehold that today's tech giants have on everything.
This really leaves us with a powerful final thought to chew on. We now have a clear path to build smarter AI collaboratively and securely. By bringing the model to the data, we're not just solving a technical problem, we might be unlocking a future that's way more innovative and, frankly, more inclusive for everyone. So the only real question left is, what are we going to build with it?